Good afternoon, everyone, and welcome to this side session discussing climate adaptation enabled through the Copernicus Services and International Cooperation. My name is Aminda Lee. I'm a British-Italian journalist, now based in Rome, ex-BBC, and I've been involved in many events discussing climate change, including at COP23 in Bonn, talking about Copernicus Services. So it's a real honour to be here today, moderating this event at COP26 in Glasgow, on the day dedicated to discussions on science, technology, research and innovation. It's great to see people here in the audience today at the Scottish Event Campus, in addition to those of you who are watching online through the European Union's side event platform Swapcard. This session is organised on behalf of the European Commission's Directorate General for Defence Industry and Space by the European Centre for Medium Range Weather Forecasts, and the Copernicus Services in collaboration with the Directorate General for Climate Action and the Commission's Joint Research Centre known as the JRC. As the UN Secretary General said this morning, we are digging our own graves, but the panel here today will highlight how Copernicus Services can help identify ways to adapt to a changing climate, prepare for emergencies, and enable policymakers to come up with the best strategies for mitigating climate change too. Copernicus is the EU's Earth Observation Programme. As Europe's Eyes on Earth, it provides information during doing Earth observation from satellites in space, combined with data in situ, in other words, from sites on the ground, in the air, in the ocean. These observations are combined with computer-based models and scientific analysis to provide a huge wealth of credible and trusted information covering our atmosphere, our land, and our oceans, as well as our air and security and emergency services. I'm going to explain how these discussions will run in a moment, but first I have some practical questions and points for you. You can send in your questions via the Slido tool. You can see the QR code coming up on the screen now, or you can actually use the event platform www.slido, and you can go and use the code COP 26 side events, and you need to choose the Glasgow panel. If you look on the Swapcard site, you can see the red box under the session description information on the bottom left-hand side of the screen. That's where you can send in your questions. And we will be running some polls today as well. So watch out for that. Now, once the questions have been moderated, you'll be able to see them and you can vote on them. And do vote, because I'll be going to the ones that you want to ask first. I'll be going to the ones with the most votes. We're going to be using Slido, as I've said, for polls, and I'm going to be launching a poll in a moment. But last but not least, please do share your thoughts of what you hear today on social media using the hashtags COP26 Copernicus and COP26 Climate Adaptation. Now, before I introduce you to our speakers in a moment, I'm going to start a first poll. And so can we launch the poll now? And you should be able to see the question on your screens. And it says, what is the most valuable climate indicator that Copernicus Services can provide? Now, what is it? So, I want you to send in your 1 or maximum 2-word answers. And if you like an answer that someone else has sent in, please send it in again, and you can, and the word will get bigger because we're going to create a word cloud. I can see people have already got their tablets and mobiles out here. So please, we'll be voting in a second. keep sending in your answers. We haven't got any answers in yet right now, but they'll be coming up in a moment. So, excuse me, it's very hot in here. As you can see, we're all suffering from the heat very badly. So we'll soon cool down in a moment. So we're going to leave that poll running, and now I'm going to introduce our speakers. So, sitting next to me, we have Samantha Burgess, who is Deputy Director of the Copernicus Climate Change Service, or C3S. Please say hello.
Hi, everyone.
Okay, next to her we have Vera Teeming, who is Scientific Officer and Researcher at the Joint Research Centre, and she's heavily involved in the European Flood Awareness System, and she's going to be talking to us about Copernicus Emergency Management today.
Hello, everyone.
Next to her, we have Carina von Schuckmann, who is physical oceanographer specialized in ocean climate monitoring at Mercator Ocean. And she's going to be discussing Copernicus Marine Service, as you would imagine.
Hello, everybody.
We have connecting remotely from Denmark, Usue Donizar, an expert at the European Environment Agency. She's connecting remotely. She's our remote speaker. There you are. I can see you. Great.
Hi.
And she's an expert at the European Environment Agency, and she's going to be here to discuss Copernicus Land Monitoring Service. Please say hello.
Hello, everyone.
Okay.
Nice to be here.
Brilliant. And our final speaker here in Glasgow is Vincent-Henri Pouc, the Director of Copernicus Atmosphere Monitoring Services, known as CAMS.
Hi, everyone.
So they're going to be starting off with a short summary of some of the ways that their particular Copernicus service contributes to helping people, businesses, and countries adapt and help people adapt to the climate that is changing, as we can see. So we're going to have a discussion about that at the moment, but let's close the Slido poll and let's see what answers you've sent in. There should be quite a few answers. Let's have a look if we could see them on the screen to see what answers people have sent in. Temperature. Okay, well that's, I'm not surprised that's number one. And we've also got sea level there as well. Also CO2. That's something I'll be coming to you about later on, Vincent-Henri, because that's something that you certainly know about. Okay, well, we didn't get many responses. Please, that's while you're logging in and getting ready. Please do get ready we'll be asking another poll later on as well. So let us now move on. We just heard that, of course, temperature, CO2, these are important things in understanding how our climate works. I'm now going to give you a little bit more background to Copernicus Services. So this is the name of our session, Climate Adaptation, enabled through international cooperation, and Copernicus Services, of course. And if we could now move to the next slide. Doesn't seem to be working very well. Here we are. Right, so this is going to give you a little bit of background about how Copernicus data was actually used in the IPCC Working Group 1 report, which came out earlier in the summer. So Copernicus services, they are not just about data repositories. They are actually not just collections of observations. They actually help us. They give us information from space combined with information on the land, the air, and the sea, all together. And they are usable for anyone, and they are usable free of charge. So these are really, really important information that you can use and governments can use as well for designing climate change policies. So, as you can see from this first slide, the Copernicus data uptake in the IPCC report that we've all been hearing about that came out a few months ago, there have actually been over a dozen data products from Copernicus Land, Emergency Marine, Atmosphere and Climate Services that were used in this report. And information on land use change and forestry, which is called LULU, CF, assessment of land degradation and restoration. So that was one thing that was used. Also, ocean warming and ocean acidification. Then we had carbon dioxide surface fluxes and climate forcing. And then we've had the so-called ERA5 reanalysis, which actually offers a comprehensive global reconstruction of the weather over the last 70 years. And that's been referenced over 100 times in the report, so you can see how important that is. And you can see that Copernicus Climate Change Service was presented as an exemplar of a climate service in the report, which is wonderful. We'll be hearing more about that in a moment. So, since the Earth's climate is a very complex system, and there are many interacting elements, we need to see how they all are measured. And so they are measured using essential climate variables. And these have been identified by the Global Climate Observing System, and they're known as ECVs. So, Copernicus Services responds to GCOS requirement by providing regularly updated data sets. And they're historical, so they go back in time, but they also show us what's happening now. And the ECVs are such as air concentration of carbon dioxide, methane, and ozone. Also monthly precipitation, extreme precipitation and flood risks, sea surface temperature, and sea levels. As you can see, these are all really important to understand what's happening with our climate. Fire burned areas, soil erosion, and glacier distribution. So all pretty fundamental. And Copernicus products also help inform mitigation and adaptation products, so not just both, and they give us also essential information about projecting what is going to happen in our climate in the future. This is why they were so commonly used in this report that we've just been seeing about a month ago. So, in our last slide, how does Copernicus fit into the global picture? Because of course it's very important, and you can see that it's a key component for the EU Green Deal, of course, if we start at home, and the European Climate Pact as well. And it's also a fundamental contribution to climate adaptation efforts through international cooperation as well, and its contribution to the group on Earth observation. Doesn't stop there, because of course Copernicus Services, they also work closely with the UNFCCC Secretariat on the international policy dimension of systematic observation. And Copernicus supports the global stocktake of greenhouse gases under the Paris Agreement with its new anthropogenic CO2 monitoring, verification and support capacity. Data from and information from Copernicus Services provides input for the monitoring of several sustainable development goal indicators, for example, those related to climate action, life below water, and sustainable cities and communities. And, of course, last but not least, services are also supporting disaster risk reduction under the Sendai framework. So, now I've introduced and set the scene, let's start off with our first speaker. Remember to send in your questions. You can do that on the bottom of the screens, left-hand side, and there's a red button saying Slido. Send in your questions there, and vote on any questions that you would like to be asked to our speakers. And with that, I'm now going to hand over the baton, so to speak, to the first speaker, who is Samantha Burgess from Copernicus Climate Change Service, or C3S.
Thank you. Okay, so I'll jump right in and It was great to see in the Slido poll that temperature came up as one of the main ECVs that people are interested in here today, with no surprise. So there's a lot of information on this graphic, but I'll talk you through it. Many people will be familiar with the graph on the top left-hand side, which is global temperature change over the last 150 years or so. You can see here that we've used several different data sets. The data from all around the world compares very well with each other, and we use this global temperature feeds into so many other climate indicators. So one of the most important regions that we've heard so much about, both in the IPCC report and in other events here today, is the cryosphere. So we know if we look at the temperature change globally, right now we're at 1.2 degrees above the pre-industrial levels. But in Europe, we're close to 2.2 degrees above pre-industrial levels. And in the Arctic, it is close to 3 degrees above pre-industrial levels. So the Arctic and Europe are warming faster than the global average. And if we go into the cryosphere indicators in particular, we can see the statistics there of how much ice sheet loss, glacier loss we've had over the last 10 to 15 years. The metrics here are provided in the C3S State of the Climate report, which is published each year. For C3S, Aminda mentioned that there are 54 essential climate variables that are defined by GCOS, the Global Climate Observing System, and C3S provides 22 of these 54 ECVs freely available on the Climate Data Store. If we go into more specifics on what this means in terms of the type of data that C3S provides, the most popular product that we have is this reanalysis, which creates maps without gaps globally. And you can see the graph on the top is the last 70-year record using ERA 5 of high-resolution information across the Earth, a 30-kilometer resolution. We have a whole family of products, reanalysis products, that are based on the ERA 5 data. So we also have ERA 5 Land, which is higher resolution again, that's 9 kilometers resolution. And then we have downscaled, localized regional reanalysis for both Europe and for the Arctic. And for the Arctic in particular, we've got very high resolution. So the resolution there is 2.5 kilometers, and it will be going back to 1991 and in near real time. And then there are so many different examples that I could have used to highlight how this data is used in terms of relevance for society. So the graph on the bottom left-hand side is looking at heat wave days in Europe. So, and the QR codes are on the slides, which will hopefully be online on social media, so you can click on those QR codes for further information. And what we do is we use the data sets, not only reanalysis, which is data for the past and present, but also climate projections, to really look at how climate will change for us around the world. And in this particular example, we're looking at how heat wave days have changed in the past in different countries. So you can see France is highlighted in this particular example. And it's the example, the graph below that is 2003. So many people in this room may remember that extreme heat wave where there were significant fatalities, particularly in France, but all over Western Europe. And we learned a lot from that heat wave to improve our infrastructure, to improve communication between different institutions, to make sure society is more resilient to heat waves in the future. The graph on the right-hand side, again, it's a topic of conversation this week and next week, of how close are we to 1.5 degrees. So this is an extrapolation of looking at the current rate of warming. We're currently at 1.2 degrees. If we extrapolate the existing rate of warming, which hopefully will change with the pledges that have been announced if they're fully enacted, but if we look at this graphic, we're due to reach 1.5 degrees around 2034. And the conversations that are occurring over the next 2 weeks will really influence whether this graph becomes a reality, whether that's an optimistic scenario, or whether it's a pessimistic scenario. So conversations matter in terms of understanding the data and creating change and really making sure these pledges take action. And I'll hand over to our next speaker. Thank you.
Thank you very much indeed. So we've been hearing about extreme heat crisis in Europe, which leads us nicely on to our second speaker, Vera Teemig, who's an expert in another kind of emergency. This one is more water related, to do with flooding. And she's now going to explain to us how the Copernicus Emergency Management Service fits into all of this.
Okay, thank you very much for the introduction. It's an honor to be here today. Talking about extremes, let's have a look. So with climate change, also emergencies or disaster change, and it's a change into the direction that they become more frequent and more extreme. If we don't do nothing or anything in Europe, every year 15 million people will be every year at the risk of forest fires. 90,000 more deaths per year in Europe due to heat waves. 2 million people will be affected by coastal and riverine floods in Europe. Droughts will expand. The tundra will disappear to the point of nothing. If we do something now and limit this heat and this global warming to 1.5 degrees, as we are pledging to, we will reduce or we will avoid 2/3 of the increased fire risk. We will also avoid 2/3 of the additional deaths due to heat waves. We will halve the damages caused by floods. And we will also have the losses due to droughts. We are contributing to that with the Emergency Management Service. So the Emergency Management Service helps Europe and the rest of the world to at the forefront of combating the adverse effects of climate change through monitoring, forecasting, and the production of experts' assessment before, in the middle, and after an event, a crisis. The crisis could be a flood, a drought, forest fire, or any other one. The Copernicus Emergency Management, as you can see here on the bottom, has two core services, components for the monitoring and forecasting. So we have developed complex models for the forecasting of flood events and the forecasting of drought and forest fire indexes. We have also built up a component for the satellite-based monitoring, and we can detect forest fires as well as floods, and we can monitor the evolution of those. A rapid mapping component provides expert evaluations, geospatial data analysts doing any type of event, any crisis. And this service is run in Europe and globally on a 24/7 basis, and it's basically for the protection of each one of you. Another, coming to essential climate variables, the talk or the topic of this session, we are also contributing with 2 essential climate variables every year to the state of the climate report done by the ECMWF. The first one is discharge. And why is it important to know about discharge and monitoring it? There are many different reasons. For one, it's impacting water management, and water management impacts everything, all the sectors, including also ecosystems and biodiversities. So it's important how the discharge is measured, and we know about the state. Last year in 2020, where you can see all the 3 graphs, I just copied in 4 different months. Overall, the average in Europe was close to normal, nothing special. However, if you look into detail, April and May were the driest months on record. October, on the other hand, was fairly wet because we had the storm Alex. Then you see 2 other graphs for forest fires. And why do we monitor forest fires? You will probably hear more about it from a couple of speakers ahead. It is important to monitor forest fires as they contribute to the emission of greenhouse gases, carbon dioxide and methane. And we need to know how many of those are emitted due to fires so that we can improve our models for climate and also for the global carbon cycle. 2020, again, looking at the European average, was close to normal. However, there were local, very strong difference in the fire danger. I'm just talking about the fire danger conditions were close to normal. However, if you look again into details, you can see that we had a very early fire seasons with with an increased fire danger risk early in spring. With the Copernicus Emergency Management Service, we are seeing that the unprecedented will become the new normal, and we have set ourselves the mission to stand by the politics, by everyone, and trying to help mitigating and adapting to those new events. And with that one, I will give to the next speaker.
Thank you very much indeed. And don't forget to send in your questions to our speakers via Slido. If you're watching on the event platform, it's on the bottom left-hand side in red. And you can vote on people's questions if you like them. And for those of you in the room, we can show the Slido QR code perhaps again on the screen. That might be quite useful. And if not, you can go to COP26 side events and then choose the Glasgow channel by going to www.slido.com. Okay, so we have been hearing about fire, we've been hearing about water, but we're going to hear about a different kind of water from our next speaker, Karina von Schuckmann, who's a specialist in ocean climate monitoring, here to discuss Copernicus's marine service.
Thank you very much. So the slides are coming. So I want to provide some specific examples, developments, methodologies provided from the Copernicus Marine Service in support of sustainable development, particularly in support of reporting for the Sustainable Development Goals targets. And before doing so, I would like to start with an integral representation, a different representation of the SDG framework based on the 3 pillars for sustainable development: the environment, the society, and the economy. It's a representation which had been developed by the Stockholm Resilience Center, in which the environment is integral and the baseline for the other 3 pillars, for society and economy. So specifically here is the example on the ocean, but it can be integrated for all other Earth system components, of course. And so with a particular discussion on the different critical important components for these different pillars for the environment, such as, for example, natural mitigation, like the uptake of carbon or the uptake of heat by the ocean, and also ecosystem services, etc. And also for society in terms of adaptation support, and for the economy in the terms of the development for sustainable blue economy. And within this, there is information on the provision of Copernicus service, marine service information, the essential variables and different products which are based on observations, reanalysis systems we have heard, and for the and remote sensing data, and for the hintcast for the situation right now, so-called nocast, and for forecasting information and replying to different markets which are listed here. So what based on these essential variables, what we have learned here, it's this concept of indicators, and those indicators, so there will be 2 examples here, which has been developed for the methodology. The methodology had been developed in the regular Ocean State Report, which is published every year, and then also implemented in the so-called Ocean Monitoring Indicator Framework as part of the reporting activities of the Copernicus Marine Service, and then in collaboration with the European Environment Agency and Eurostat, directly supporting for SDG 14 and SDG 13 on life below water and climate action. So these are the specific examples here for ocean acidification and eutrophication. So ocean acidification is so-called reprocessed product, and this is a global average of the situation of today of the ocean and how it evolves in terms of the acidification since the mid of the 80s. And this methodology had been provided, and as I said before, in the issue 4 of the Ocean State Report, so you're well invited to further learn. And this indicator is then published in the Ocean Monitoring Indicator Framework, then submitted to Eurostat, which in turn has used this in terms of the regular reporting under the SDG 14.3. Then there's eutrophication. There's a specific target on 14.1 on the pollution in the ocean with the terms of eutrophication. And also here there's a new methodology which has been put in place in issue 5 of the Ocean State Report, and there's further development also at the level of the economic zones, and directly also delivering the path through Eurostat and then in the reporting of the SDG. Just to provide you some examples on direct data support in terms of at the interface of science and policy and for sustainable development. Thank you.
Thank you very much indeed. Now let's move away from the oceans back onto dry land, and let's hear from our speaker who is connecting remotely, Usue Donezar, who is joining us from Denmark, and she's going to be discussing Copernicus land monitoring services. So let's hear what you have to say. There you are.
Hello everyone. It's my pleasure to be there. Next slide, please. Okay. No, the first one. That's it. Thank you very much. So this is this diagram represents some of the key points of the European Green Deal, and I'm sure that this sounds familiar to almost everyone in the room. And for those who haven't heard of it before, let me tell you this: this diagram is going to be in this conference all around the place, and not only because we are lazy speakers. No, the reason is that it illustrates the European Commission priorities for the 2019 to 2024 period. And these priorities, they set specific and ambitious targets, all of them related to climate adaptation. The first one is to ensure zero net emissions of greenhouse gases by 2050. The second, to facilitate the decoupling of economic growth from resource use. And last but not least, to make certain that no person or place is left behind, because this must be a just transition. Today, I will present one example of the Copernicus Land Monitoring Service product being used in the context of this policy. It's not the only example we have, but I will focus only on that one. One that specifically relates to increasing the EU's climate ambitions for 2030 and 2050. Because we aim at achieving climate neutrality by 2050. And this will require a huge effort. We must significantly decrease carbon and other greenhouse gas emissions. And we must significantly increase carbon storage. In this context, and in the spirit of the Green Deal, the land use change and forestry regulation, already named by Aminda, the LULUCF regulation, was adopted last July. This regulation specifies that greenhouse gas emissions and removals from land use change, and forestry be included in the 2030 Climate and Energy Framework. The LULUCF regulation implements a long-standing agreement between EU leaders. It specifies, no, please, go back to the previous slide, please. It specifies that all sectors should contribute to the EU's 2030 emission reduction target, and this includes the land use sector. And whenever we speak about cutting off emissions and accounting for carbon storage, we always face the same challenge. We have to know how to measure our progress. And this is where the Copernicus Land Monitoring Service enters the playground, because we have been producing land cover and land use products operationally since 2012. Next slide, please. We are operational since 2012, but we are not static at all. We are seeing evolution, not just driven by technical aspects, and believe me, there have been plenty of them in the last years, but also by policy context. The European Green Deal has been one of the key policies. It has been instrumental in the redefinition of some of our products and in the evolution of others, and one of them is the Green Land Cover. The Green Land Cover shows land cover for the whole European economic area. This product was first released with 1990 as reference year. I was only 10 at that moment. It has been updated 5 times ever since. Its evolution, what we call the Green Land Cover Plus or CLC Plus, and it's shown in this slide, will not only be a land cover map. The CLC Plus will be a data cube. This means that we are building a huge database. In this database, for each of the objects, such as crop plots, that we have included in what we call the CLC Plus backbone, we calculate different attributes. These attributes describe land use characteristics, and most of them are calculated based on satellite imagery. This database approach will allow us to create a set of different products related to different themes. And each of these products, we call them instances. And the first one will be the LULUCF instance, which will be released next year. This product aims at giving information related to carbon storage based on satellite-derived parameters. And it's a very good example of how the CLMS product aiming at becoming a fundamental tool for carbon accounting. So this is all from my side. I hope this information has shown the importance of these initiatives and of the Copernicus Land Monitoring Service in the context of climate adaptation. I will be very happy to answer any questions you might have afterwards. Thank you very much.
Thank you. And now we're going to round off this set of presentations, hearing from Vincent-Henri Pouc, who leads Copernicus Atmosphere Monitoring Service, or CAMS.
Yes, thanks, Aminda. So I will come back to the question of wildfires. So wildfires are very interesting essential climate variables for many reasons. The first one is that it's both a consequence of climate change, and when flammability of vegetation increases due to drought and high temperature, the risk for fires increase. But it's also a driver for climate change, because the emissions of greenhouse gases, but also of aerosol, can play their role in the climate system. So wildfires are interesting also because in the context of a program like Copernicus, because monitoring from space is possible. Satellites can remote sense the heat coming out from the fires. So it is possible to see almost in real time the fires that are burning. And I want to talk about the situation of this summer, focusing on the left part of the slide. You've heard in Europe a lot about fires in the Mediterranean area with Turkey, Greece, Algeria. But also maybe the most striking event was for a number of years in a row, very extreme fires in Siberia, in particularly in the northeast of Siberia, called the Sakha Republic, where these fires, you have the picture here, are burning, not vegetation, but peatland. And this is a big concern. Not only it's when you see the time series, you see that for this part of the world, the Sakha Republic, emissions of carbon have increased dramatically over the last almost 20 years. But also it's a concern because while peatland is burning, it's unlocking another carbon store on top of thawing of permafrost. It also changes to the landscape that will affect the carbon cycle, and also what we call the albedo, which is the reflective properties of the atmosphere. And also through the plumes from these fires, soot, black carbon can be deposited far away from the fires and change the reflection of radiation on sea ice or on ice. So the fires are evolving, in some cases dramatically. But what I wanted to show on the right-hand side of the slide is the same indicator, the quantity of CO2 emitted year after year at the global scale. So when you sum up all the emissions of CO2 due to wildfires, what you see is a decreasing trend. So this decreasing trend is driven by the trends in the savanna fires in the tropics, which are going down. But of course, it masks all that is going on, and I mentioned in the extratropics. The point is that it's not enough to monitor global indicators with one figure. You really need to see the regional differences and the far-ranging impacts. As I mentioned, the plumes of aerosol blackening the sea ice, which play their role in the Earth system. What I want to talk about to finish is about emissions of greenhouse gases. And in fact, maybe one does not often realize that the emissions of greenhouse gases and of pollutants are the most direct link between human activities and the climate system. It's really through the changes in emissions and also in the use of in the land use that will impact the concentrations of greenhouse gases and pollutants in the atmosphere. And you may be surprised, but in general, it's not possible to measure emissions. What is measured is atmospheric concentration. And emissions are only measured rarely in big field campaigns where focus can be put with lots of devices on one area. So it's a problem in the context of the COP process because you know very well this basic principle that one can only manage what one can measure, and if we are not sure about the emissions that are emitted today, how can we take the best decisions, and when decisions are taken, how can we know if they are effective or not? So the way emissions are estimated today, and it's the bottom of the slide, the bottom left, it's based on activity level accounting. So at the country level, people will count the amount of fossil fuels that are used for instance, traffic, that are used for energy creation. And from there, as an accounting exercise, they estimate the quantity of CO2 that is emitted. So it's so-called bottom-up emissions. Now we know that satellites, but also from in situ, you know this Mauna Loa curve, it is possible to monitor many constituents and CO2 concentration in the atmosphere. And the idea that we are pursuing in Copernicus is to use these Earth observations from satellites, but also from in situ, and numerical models to try convert this information in the atmosphere into information about emissions. And that's what we call top-down emissions, so using observation of concentration to derive the emissions. And it's very rich, actually, to compare the top-down emissions, which is what we get through trying to close the loop with atmospheric observations, and the bottom-up emissions in order to progress. So it will not give the final answer, but it will point the people doing the emission accounting in the areas where the laws of physics and what we know and the observation in the atmosphere do not coincide with what is estimated. And as I wrote in this sentence, it's very important because you often you cannot you cannot account for what you don't know. And with this method, because the satellites and the in situ observations measure all the CO2, you can find out about unknown unknowns. So what you don't know, you didn't know, you can find out with this method. So it will support a lot the process, the stocktake process that Aminda mentioned in the introduction slides. And it's already not for CO2 but for methane a reality. As part of the Copernicus Atmosphere Monitoring Service, we provide estimates of the emissions of methane based on observation, in that case surface observations, as you can see on the map here.
Okay, thank you very much indeed. Well, that was a quick introduction to all the many things that the Copernicus services, all the different elements provide. And I see that you've already started sending in your questions, which is great. Please do carry on and send in some more. I'm actually going to start off with well, it was something that ties in with what you were talking about, Vincent-Henri, just now, which was talk of the need to close the loop on carbon emissions. And the question is, what does that mean and how can Copernicus Services help?
Yes.
Very briefly.
Yes, it's basically what I have said. It's needed to have a possibility to verify whether the current estimate of carbon emissions of CO2 and of methane are coincident with what is observed in the atmosphere. And closing the loop is using numerical models. With these numerical models, you plug in the figures of emissions, you plug in the laws of physics, and you derive what should be the concentration in the atmosphere, and then you compare with the ground-based or the satellite, and if they don't match, you know that the loop is not closed and that you must look again for other sources or other sinks of these greenhouse gases.
Okay, thank you. I'm just going to a couple of other questions that we've got sent in here. We've got one that I think I'm going to ask Karina and also Usuwe, who's on the line remotely. And the question is, we see increased emphasis links between climate and biodiversity policies. What do you see as the next generation of product services to address this for ocean and land domains? Karina first.
So I think the reply could be very diverse. So I will start with one example. So for example, the discussion on how, for example, a combined use, so combining science knowledge and data together with economy, for example, is to use an approach of a so-called ecosystem approach, where you use different essential variables. You put them together, like, for example, temperature, salinity, chlorophyll, ocean pH. And with this, you have a more comprehensive view on the ocean. And with this, you can provide a more comprehensive information in terms of supporting fisheries management, for example. And this, in turn, will provide a pathway in order to sustainable development. So this is just an example on how the data can directly support. Another example is a general example on the role of oceans data services to support the ocean climate nexus and ocean governance. But I mean, this is a long topic, so I think I stop here with this specific example first.
Thank you very much indeed. And just getting our remote speaker her answer as far as the land is concerned. Usuwe, what do you think for biodiversity?
Well, I think that what the Copernicus Land Monitoring Service is providing, the information on regarding the land use and the land cover and the changes that are happening in the land cover, I think that's essential for us to monitor if we are achieving the targets set by the European Green Deal, if we want to achieve, if we want to monitor the natural restoration also. And also the example I gave with the LULUCF regulation, I think that is a very good example of the integration of different databases or of different data sources to achieve a common understanding of what is actually happening in the land.
Okay, thank you very much indeed. And Samantha, you wanted to add something?
Yeah, it's a really interesting question, and building on what the other two speakers have mentioned, one of the things that we do at the Copernicus Climate Change Service is really look at how climate data is relevant for a whole range of different sectors of society. So we have an application which looks precisely at this, at biodiversity sensitivity to a warming world. So anyone can go on the climate data store, look at this application, look at biodiversity, and we've got case studies from around the world, from both terrestrial samples and oceanic examples as well, and really look at the climate sensitivity of different species to a different range of projections of our potential future climate.
Okay, thank you. Vera, I have a question for you. Hopefully, even though you're an expert on floods, hopefully you might be able to answer this. The question is the emergency information distributed to other agencies? For example, the European Centre for Disease Prevention and Control, for example, the spread of mosquito-borne diseases. I don't know if that's...
Okay. Well, the first part of the question I can answer. The example doesn't apply, but yes, the emergency information are spread. So for some of the emergency, it's open source information. Others are targeted for other agencies. For example, in the case of floods, if we have notifications and we send it out, they are basically our messages to create early awareness of an upcoming event. And we are sending it to the organizations in the countries, in the regions that have the mandate to warn the population. We are not having the mandate. So we are basically in contact with the institutions that do have that. For other emergencies, it's different. We are not monitoring the mosquito spread, so I can't answer that particular example. But we do work together with the public and also with the specific institutions.
I'm sure many people will remember the floods, the terrible floods that we saw this summer in Europe, in Central Europe. How was your service involved in that particular thing?
Yes, yes, it was devastating floods, most on our doorsteps. Yes, we saw the floods coming, or some floods coming, about 4 days ahead. We sent out some notifications, and the national institutions were also aware of this. They kept monitoring, increasing their staff for monitoring, and also they estimated large floods. So they also prepared for the worst that they have known. The worst that they had experienced was in 2016. It was a 100-year flood, and it was also catastrophic. They did prepare for that. But what they were facing was a flood with a more than a 1,000 years return period. And what it means is a flood that appears statistically once in 1,000 years. So they were faced with something that is unprecedented and they could not have prepared for. And that unfortunately explains also the amount of damages that happened to road infrastructure, houses, but also the large loss of people, number of lives. And that's also a point that we are taking into considerations. We do have to prepare for the unprecedented. We did forecast the event. Everyone knew about it. We did prepare. People were prepared, but we were faced with something that was unimaginable and that caused a lot of damage.
Of course, the problem is that we are now seeing more and more of the unimaginable for all of us. And
exactly, it is becoming the new normal, and for that, it's important to get prepared for that.
Exactly. Now, talking about, we've had one thing, which is we've had too much water, but I believe that in a question that we've had here, it says, I believe that Copernicus data revealed there was very little wind in Europe this year. Now, why is that data important for policymakers? Who would like to answer that question? Samantha?
Yeah, sure. So one of the most critical components of our energy transition is using renewable sources, and one of the most accessible renewable sources, particularly in Europe, is wind energy. And we saw over the spring and early summer that it was stiller than expectations than expected. And this has huge implications for energy generation. So again, I mentioned previously that we have different applications that look at particular issues that are relevant to society. So we have an energy application as well that looks at forecasting wind and the implications for that. And it compares it with temperature as well. So we had quite a hot summer, which meant there was a greater energy demand. And again, when it's a colder winter than average, it changes the energy demands. So understanding and being able to forecast very accurately in different regions and different valleys and very localized events is really important to feed that information to the energy providers.
Okay, thank you very much indeed, and also perhaps to policymakers deciding where they're going to, what kind of energy mix we need.
Exactly.
Which is so different in each country. Yeah. Vincent Henry, there's a question specifically for you. It says, the peatland emission example was fascinating and worrying, and I imagine has quite significant consequences in policy discussions.
Sorry, I didn't catch.
It was the peatland example of the burning peat,
Yes.
and the question is, it has significant consequences when we're discussing about policy.
Yes, because fires that burn, the type of fuel that is burning makes a big difference, and the area where things burn makes a lot of difference. And peat is accumulated over hundreds of years, so it's not the same to see resources burn when it is changing a state of play for several hundreds of years. So it is a concern to see these areas burning. It is also a concern to see fires occurring in areas where they did not occur so far. because there are areas in the world, in the tropics, where fires are just part of the natural cycle. They happen, etc. But there are other areas where the last few summers, so I can mention Australia, North America, where the fires that have been observed in the last few years have been completely unheard of, unprecedented. So again, it's the same story like for floods. It's really concerning to see these events where in the past we are talking in terms of return duration, like Vera was doing. Now things are changing so fast that it becomes meaningless when something can never happen. When it happens, it means that our planet is changing.
Okay, we're almost coming to the end of this session. It's very hard to believe. We do have a few more questions, but there was something I wanted to ask you, Samantha, which was that your service is going to be contributing to the IPCC Atlas. Can you tell us a little bit about that?
Sure. So I'm sure everyone listening online and in the room is familiar with the IPCC sixth assessment report for Working Group 1, which was published earlier this year in August. As part of this IPCC production, there was the IPCC Atlas, which enables decision makers and anyone interested to really look at climate projections for their city and for their region and understand the differences with different types of future scenarios. So whether the pledges that are committed to right now will be enacted, or whether it's a less optimistic scenario where emissions will continue to rise. And C3S is working with the developers of the IPCC Atlas to make sure that we can host it in the future, so society won't be waiting until the next IPCC assessment publication for an update to that atlas, but we'll be able to update it annually or even more frequently than that to make sure the climate data is as up to date as possible for people to make decisions with.
Okay, thank you very much indeed. Okay, well, I think even though we do have some more questions, they will be answered in the chat. Thank you for sending them in. That's greatly appreciated. It's always good to know there are people watching out there and wanting to ask our prestigious guests more questions. And what I actually would like to do now is to actually ask you, the audience, a little question in our almost final poll, because I want to know what you've taken away from this session. So if we could launch the second Slido poll, and again we're going to have a word cloud, so the more entries that you see that you like, send them in, and the bigger the words will come in front of our eyes. And the question is, what are your main takeaways from this session? So not a difficult one. Then again, maybe you've got multiple ones, so you're going to have to send in multiple times, but please do, because we're interested to hear what you've taken away. For example, the peatland example obviously struck one user in particular. And while I leave that word cloud on, I'm going to leave it running. Just to like to remind you, those of you in the room, and of course those of you watching online, that you can find out more about Copernicus Services in the EU side event online exhibition space, which is going to be opening very shortly. We're hoping tomorrow. And in that space you can find videos explaining exactly what everything is. There'll be fact sheets and there's brochures, and you will certainly be able to ask further questions there. And it's hopefully starting to be open from tomorrow. The video of this particular session and the presentation slides that you saw at the beginning will be available on the Copernicus Climate Change Service website, which is climate.copernicus.eu, and via the EC COP26 side event platform Swapcard, which you're on now, of course. And here we're seeing the word cloud. So we've got wildfires, yes, Earth observation, emergency management services. Okay, that's quite a long one, emergency management services and Copernicus, but thank you for sending it in anyway. Do send more things in as well. Data available, yes, that's good. And yes, policymakers now need to understand and use it, very important. Okay, right. Well, thank you for taking the time to send in those answers. For those of you already not familiar with using Copernicus data, there are many training events throughout the year, both country and also theme specific. So we've heard some of the themes today. So you can just visit the Copernicus websites to find out more and sign up. And I'd like to conclude this event on behalf of the organisers by thanking all our speakers today, including Ursay, who's online as well. Thank you. A big thanks to the organisers behind the scenes. And thank you to the technicians in the room for making everything work so perfectly. And of course, a big thanks to you, the audience, for your participation and for sending in those questions and voting on questions. We would really appreciate your feedback, particularly as this is the first virtual thing that we have done for COP26 online. So before you leave, we're going to open another Slido poll just to ask you how to rate this session, if you found it useful or not. The poll will be running. And if you have more questions, please send them you can send them in via the Copernicus online stand when it is open. And with that, we will leave this poll open, but from me, it is goodbye from Glasgow. This is me, Aminda Lee, wishing you a good rest of the evening.